So that's why I want to deep dive talking why did the cow cross the road 3, which is coming from 2017 bronze February session. Okay. And again, I assume people read the questions. Let me get to material. All right. So I see people just joined the sessions. Now we are on topic 4, starting with the session 3. Session 2, we are going to talk why did the cow cross the road. All right. Like I said, so everybody do please uh, get through the questions before the session, so we don't have to spend the time to comprehend the session. And also, I see new people join for today. Here's the deal. This launch meeting, we focus on very basic algorithm for people who gonna take a bronze and a silver for this year. Um, though it's gonna be very different as to the bar, targeting for silver versus targeting bronze. But do it again. There's a lot of footprint working around very basic algorithm. So I think it's worth the time. So my end, I offer such a launch meeting, which is a 4 session already. Hopefully people can follow that, making sure there's no loopholes or any footprint or corners that you need to, basically making sure you're started with those basics. All right, so take a look at this question. Let's quickly read through the questions, then let's get to the solution path. FJ, in his old age, has unfortunately become increasingly grumpy and paranoid, forgetting the extent to which bovine diversity helped his farm truly flourish over the years. He has recently decided to build a huge fence around them. A second, please. Um, so he has recently decided to build a huge fence around the farm, discouraging cows from neighboring farms from visiting and completely prohibiting entry from a handful of neighboring farms. I mean, all of this is the context. The cows are quite upset by this state of affairs, not only since they can no longer visit with their friends, but since it has caused them to cancel participation in the International Milking Olympiad, an event to which they look forward all the years. All right. Now let's get to the second paragraph. Neighboring cows that still have the ability to enter farmland properties find the process has become more arduous, as they can enter only through a single gate, where each cow is subject to a intense questioning, often causing the cow to queue up in a long line. For each of the N cows visiting the farm, you are told the time she arrived at the gate and the duration of the time it requires for her to answer her entry questions. So here, only one cow can be undergoing questioning at any given time. So if many cows arrive near the same time, they will likely need to wait in line to be processed one by one. Right? Really, we have something which is relevant to the question. You have N cows, and the cows had to go through this questioning process, and only one cow at one time so far. That's what we have. If many cows arrive near the same time, they will likely waiting the line to be processed one by one. For example, if a cow arrived at time 5 and answer questions for 7 units of time, another cow arriving at time 8 would have to wait until 5 plus 7, which is 12, to start answering the questions for herself. Now, look at the question. Please determine the earliest possible time by which all cows are able to enter the farm. So that's the question, straightforward. Let's look at the use case example. So as to input, the first one input is N, which stands for what? The physical meaning of N is N cows. A positive integer at most 100. So for new people joining sessions, you need to be very careful with the scale of input numbers. If that input number is a function of your algorithm, so they're going to decide the time complexity you're going to deliver, right? So this is very intensely in silver, but also you can reflect in the bronze really well. Each of the next inlines describe one cow given the time it arrived and the time it required for questioning. Each of these numbers are positive integers, and most is 1, 2, 3, 4, 5, 6, 10 to the power 6, okay? And 10 to the power 6, like I said, you need to be sensitive to the numbers. 10 to the power 6 equals what? Log 2, 10 to the power 6. Making sure this number can be represented by 32 bits, which is clearly yes, because 2 to the power 3 equals 9. 2 to the power 3 point whatever, 3.3 around equals 10, right? And then, and putting 6, definitely 32 bits is good enough. I mean, just taking this as an example, people, you need to be very sensitive with the input number scale so that you can decide the time complexity for the algorithm, and also can decide whether or not you have to represent the data with the correct type. Now, output, please determine the minimum here, minimum possible time at which all the cow could have completed the processing. Interesting. Now, look at this example. You have 3 cows to be questioned. So the first cow arrived at 2 p.m. I'm sorry, 2 times 2, and take 1 to be questioned. And then the next 2 cows, one is arrived at 8 and it's be questioned for 3 unit time, and the last one is arrived at 5 and be questioned at 7 unit time. So the total time, folks, the minimum possible time at which all the cow could have completed processing. So for this example, that's a 15, which is very simple. So the first is taking the first cow, from 2 to 3, right? Get it down for the first cow. And the second cow definitely want to arrange with the 5, 7, 1 instead of waiting for the cow arrive at 8 while the cow already arrived at 5, still waiting there for nothing. So, and then 5 to what? 5 to 12, right? And after that, while the second cow finished the question, and you know what, the cow arrived at 8 already waiting there, but she will not have a chance until the second cow finished at the 12. So the next one gonna be what? 12 plus 3, gonna 15. That's why the answer is 15. It's a simple example. Also, this question, I would just say easy level. I put that in our file. But this is a typical question. It is, I would say, greedy algorithm with sorting. And we have a session talking about greedy for my bronze and 50 server, and also advanced server. We have very intensive greedy discussion. One type of question for greedy algorithm is very frequent associated with the sorting. So you have to sort it out so that you can fulfill this greedy algorithm. And more important than that is, how would you justify this greedy algorithm? To be honest, for this question is not exactly the best vehicle to represent the greedy algorithm. But let's still try to interpret this question. Think about this way. You have n cows, and n cows should go through that gate one by one, isn't it? So what does it mean? I mean, the minimum time you gotta tick is you gotta group all the time for each individual cow all together. That's gonna be the minimum time for all the n cows to get through the gate. But reality is, some cow are gonna arrive ahead of the cow while doing questioning. So in other words, you had to wait. Now, to translate the problem, you're gonna think about this way: is you can think about, you have a lot of segments, right? This segment represent the start and represent the end, as opposed to represent the data here. So this is a problem you're going to translate as to that trying to make waiting time. I'm sorry, the waiting time here is trying to make the time, which is the gap for ice cow, for the juice cow, making sure we don't want to see a gap between the ice cow finish the questioning and the juice cow start the questioning. Why is that? Because the total time for the n cow to get through the gate is minimum going to greater the total. All this number adds up, right? The time it takes for questions for each cow. So that's going to be the minimum. So as for the total time to be minimum, you have to making sure, right? The gap, the time is in between the two cows, you know, in that questioning, you want to making sure the gap as small as possible. That's it to transfer the problem down to component levels, right? So with that being said, let's get to the schedule here. All right, let's start the document. I will show that in kind of detailed manners, which is I'm actually want you guys to do the similar thing in your mind or just type it down before you dive in any coding. So for this question, we need to translate in component level. So the driver is that the minimum time for n cows get through the gate. In other words, finish the questioning. Got to equal, greater or equal than what? The total question time for n cows. Yeah, the first cow, ice cow starting at right. You have J cow starting arrive time at J, and the time it's taking is PI. This is PJ. So the total question time for the n cows, which is sum up the P from 1 to n, right? Which is right, correct? That's going to be the minimum time. So the really time, the time they're going to decide the answer, the minimum total time, which kind of equals to the total questioning time, plus what? Plus the gap. The gap time. So the gap time, what a dynamic gap time is that after Pascal finish questioning, and after gap time, Giscal starts questioning, isn't it? That's going to decide the total time. Well, you want to ask them the total minimum time, so you want to making sure the gap time to be what? To be as small as possible, isn't it? That's all about for this question. Now, how to making sure the gap time as small as possible? But there's a lot of scenarios you can think about. The first scenario is the first question you're gonna ask, who's gonna be the first cow, right? Who's gonna be first cow? Definitely the first cow gonna be the cow gonna arrive at the first time, gonna arrive the earliest time. You can actually prove that by show the contradiction is wrong. Think about it. In order to have a very short gap time, there's no point you're gonna leave the cow already arrived, waiting there to have the second arrived cow to start the questioning. What is the point? Because while you have the first arrived cow waiting there, isn't you increasing the gap time? So in that regard, you want to making sure when ice cow finish the questioning, the next cow to come up gonna be the cow who arrived right after the ice cow. That's why we have to sort it out, right? So for this question, this kind of layer of translation, problem translation is not that difficult. But this week, I'm pretty sure that's kind of like a warm up, it's like a teaser. But I still want to have that in part of our series sessions. Remind people is typical USACO questions, especially for server and also bronze included. The first, you had to translate the problem down to component levels. Component levels is literally a raw question, and you had to use whichever algorithm or data structure to sort it out. But this translation part, we have a lot of good discussion in my classes. We have a simulation, we have a starting back, we have a downgrade problem. So all this method you guys should use it here. So first to translate the problem down to component levels. And look at this question, the component level that is, you have to sort it out the cows based upon the arrival time and then transverse it to calculate the total time. In other words, calculate the total gap time. And even on top of that, for the translation part, as our discussion here is, in order to cut down the gap time, we have to make the cow arrive earlier to have the highest priority to get the questioning, right? So with that, this algorithm down to component level, going to be sort the cow based on arrival time, right? And then what? Simulation to find total time. So here, simulation. Simulation is our first session for the launch meeting. We talk about simulation. And for bronze level, mostly simulation is literally do whatever the question tells you to do. If the time complexity allows you to do that. So which is you can treat as a brute force. But it's not exactly a brute force. Brute force is your algorithm. You get the algorithm from very superficial restriction. You reflect in your coding. That's called brute force. But for simulation, it's literally you simulate that process to get the results, get intermediate results, all the way down to the final answer to return. So that's the first level of simulation. The second level of simulation, like the cow dancing, I guess people take my bronze class also taking that question. So that simulation, you're gonna relies on data structure, for example, priority queue, so that you can continue that process. Such as, can you tell me who's gonna be the next cow to get on the stage? Well, based on logic, you're gonna find the correct data structure to help you on that. So look at this one. This is after sort out the cow based on the arrival time. This is literally to just a one-way transversal. You can get the answers. Well, still belong to simulation. Okay. And with that, I think the logic is rather clear. So we can go ahead and put it out. For today, I don't think we're gonna burn 45 minutes. It's quite very simple questions. Now let's go to the questions. The question. Cow Q, okay. All right, let's grab the template. So the template is the template to grab the input and also output, which is very routine stuff. We don't need to spend time on this part. All right, let's get started. So first of all, you want to know the input n, right? It's int next int. Don't forget the fifth meaning of the int. You're gonna have an n cows to get question so that they can pass the get, right? And next one is you want to record the cow's arrival time and also the time it takes to go through the questioning. So definitely this you cannot sort it on the fly. You had to record it in your 2D array and then sort it out, right? Actually, most questions you had to record it down, and then apply your algorithm such as sorting on it. Okay, but some questions you can do on the fly. For example, for some graph problems, you can take whatever pair of numbers, you can build up the graph on the time at the same time. And talking about the graph for bronze people, graph topic is definitely on your plate. For people who take my bronze and the basic server, please do not get impression that for the following chapters, you think that belongs to server, which is not, which is to belong to bronze. I put basic server is like a bridging. Sometimes the boundary between the bronze and the server is not that clear. So you have to be started with all topics, all 11 footprints for the class, making sure you schedule your offline time well to handle the chapters on your schedule. If you think you do not have a very solid plan beside our launch meeting. So basically, I want to push you guys to spend time on that. Try to go back to the coding session questions and homework, making sure you can deliver that at least. Making sure, even though you deliver the code, please deliver one more time again as a way so you can follow the total 11 chapters. And meanwhile, if you guys have offline time, I better you have. So try to taking more bronze questions from recent years, for recent 5 years at least. All right. Now, talking here, we want to record it down. Each cal's arrive time and also the time it takes to finish the questioning. So definitely you want to having a 2D array, right? This 2D array is gonna have n rows and it's gonna have 2 columns, which is the arrive time and the time it takes for the questioning. And record it down, right? So clear that I'm using Java. For people using C++, you're gonna have a less typing here, but that's not the point. And you're gonna record the first one. The first one at index 0, that's the cal's arrive time, right? And the second column that records the cal, how long it took to finish the questioning for that given cal. There you go. After that, close the input file. And definitely we had to sort it out, right? Because we want to making sure, because the algorithm that we define is making sure who come earlier, who get to the get, or at least the get in front of the line if there's a cal in questioning or the get. So you gotta sort it out. Sort it out one more time since we have new students. So please do not using any derivative sorting algorithms such as selection sort, insertion sort, bubble sort. You literally do not want to using any your own defined sorting algorithm, just called API. The reason is very clear. You want to using n log n for the time instead of n square, right? So people just remember that. And you want to sort. So here for the sort, as I mentioned from last session, you had to be very solid to sort on existing class, objects of existing class who that already implement the comparable interface. So you can just be using that and sort it based on natural order. And also you also have to be very solid to sort the objects of your customer class. And so you have to deliver how to compare in order to implement the comparable interface, in order to implement the comparator. So you can pass in that arguments in that, right? So hopefully people can understand what I'm talking here. So making sure sorting algorithm, sorting API, you can deliver, all right? So this one, you want to sort the input based upon what? Based on the attributes of arrive time. So this one, you can pass in a comparator object. And you had to give a message, right? So just compare at the first column. So who arrived earlier? you want to put that high priority. So with that, just sort it out. And what is next? Next is just a one-way traverse of the simulate, right? Literally, what time it takes for the first cal, and then go ahead with the second cal. Second cal gonna have 2 scenarios. One, second cal hasn't arrived yet, right? It's kind of lazy, hasn't arrived yet, or the second cal is waiting there. So that's literally just a one-way traverse. So you're gonna record this all the time, right? So with that, you're gonna have an input result. That's answer gonna return. You can go ahead and record the first cal. What is the time the first cal finished questioning? So that's for sure, right? So this is gonna go to with input with the first cal, its arrive time, and also what time, how long it takes for the first cal to finish the questioning, which is just add up, right? And after that, you're gonna have a loop from 1 all the way to time and R plus plus. And from here is going to have a just, like I said, two scenario, right? Discussion. Okay, if the next cow for its arrive time, which is a greater or equal than result, which means, you know what, the second cow hasn't arrived yet or just arrived while the first cow finished the questioning. And with that, your result gonna what? Plus equal. The result gonna equal what? The result gonna using the next cow starting time, which is I0 plus in how long it takes, right? Which is I and N1. Or if you know the previous cow finished questioning, the second cow is already waiting there, so it's your time. Just come up, and then the result gonna plus equal what? So the time for the second cow to start the question is going to be exactly the time for the previous cow finish question. That is the result value. So just result plus equal what? The time it takes for the next cow to finish the question. The input is going to be I1. There you go, right? And after that, just wrap it up and return. Let's go through the code, but I want to remind people, so there's a new people joining the session. This is a very simple level question, not a very representative, supposed to be, even we are talking about a very basic algorithm. But I still want to including those questions to remind people about the process as to translate the component levels and then deliver the code. And especially for these questions, very relevant to greedy plus sorting algorithm. Okay, what's the time? Now, before you commit the code, why don't we just go through the code one more time before we submit it? So first of all, we record each cow's arrive time and also the time for questioning and into a 2D array, right? The size equals n. You're gonna have two columns. The first column represents time. The second column represents the time it takes for the questioning. And then we had to sort it out. We need to sort each cow based on her arrive time. So, so this is very basic algorithm. If you're using version after Java 8, you can have just a one line to deliver the same function as well. But this one is to input a object of the class that implements the comparator. So then you have to override the compare method. And clearly we are compared at the first column, which is our time. Whoever come earlier, who has the higher priority to get a questioning. And after that is basically similar. Though it's just a one direction traverse, which is actually belongs to simulations. And we're starting with a result variable to record the total time going to return. So for the first cow, since the first cow got to be the first one to start a question, so we know what's going to be the time for the first cow to finish the question. So that's why we record that into the result, which is input as the first element, first column, arrive time, plus the second column, which is time it takes for questioning. So that's going to result. And then for this for loop, you're going to start simulating from the second cow. And there's two cases, right? Like I said, when the previous cow finished question, the next cow hasn't arrived yet or just arrived. If so, then just the result. What's the fifth meaning of the result? Don't forget about that. Result is going to be the time for during your traversal for this given cow. Let's call I. When cow I finish questioning, what is the time? So that's the fifth meaning of the result. So that's why when the next cow just arrived and also not yet arrived when first cow finished questioning, so just reset the result as using that given cow. At that given cow start time and the time it takes for questioning, right? That's the first case. The second case is the next cow is already waiting there. Well, then the start time for the next cow gotta be the end time of previous cow and add on and add what? The time it takes for the questioning. So that's it. And after that, just write in the answers. And for the format, you want to use cal q as input, as output, and also So this is just for your FYI. You're checking your answers, and after that, you close the app file. Since today's session is, I don't think not as much as previous sessions. I want to remind people one more thing is while you guys reviewing our sessions, do please practicing your debugging. I think I mentioned about that several times in our sessions. In order to why you need to debugging, two reasons. First reason, in your context, you can have the first use case, which skill-wise is a very small. You literally can deep dive in your code and making sure every step in terms of variable, which is agrees with your algorithm, your logistics. And the second reason you have to do that, if you cannot pass the first case, which means if you not check you against with else, mostly it's going to be wrong answer. So what's the point? So placing the breakpoint into your main logic and show that from your windows. I think I show people that. So since for today, why don't we just quickly show that again? Let's say you have a bug for this code, right? And if you look at the structure of your code for the sorting and also recording down the input, which is very tedious stuff, less likely going to have some bug within it. But if you're not sure, you can print it out this array, making sure you can get the correct order. And mostly the simulation, I mean, for this code is also very simple, but most simulation is coming from this for loop. So you can put a breakpoint. And after that, you can go ahead with debug. And actually, I need to have the effective file so that you debug. But you can go ahead to run as a debug. Once you hit that, then you can step over for each step. And meanwhile, you can show the view of all the variables. And while you click step over, you can check the variables. They can show the intermediate results while you go through each step. So that is a very, it's very basic but very helpful way for you to deep dive in your code, making sure you can pass the first user case. And for today's sessions, I don't want to spend time on that, but for following sessions, if there's any volunteer who finished my assigned questions but still cannot figure it out, maybe you can contact me. I can use that as a vehicle to show maybe next sessions. That's really to show that debugging if the time allows. All right, so you guys have my email, you can come to me. All right, so that will be the code. I think we are ready to check the code, right? So go to here. If you have not yet registered account, just go ahead and do that, right? Just take like 30 seconds. Very easy. You can get accounts so then you can start practicing the checker code under analysis mode. All right, so we are using Java and then choose a file, which is going to be the Java file, which is this file, and choose it and submit it. You see here, file missing and file missing. So which means let's double check our file. The file should be calq. Go ahead here. calq. Oh, I think you see, when we change the file, the two files, we did not save it. I think that's a problem. Still recorded is something different file name. So we have a save it. Let's try again. All right, there's no surprise for these questions. Like I said, it's very easy level questions. And also, if you look at input across the 10 user cases, we see the time is quite uniform, 200 milliseconds, 200 milliseconds. So the scale of the user cases is just very small, and also space-wise is very consistent. So this is not a, to be honest, a very typical use case question. Supposedly the use case-wise gonna check your code, behind different levels. The first several use cases very small levels, and while more use cases they're gonna check over very uh, large footprint of input data, and with that, gonna check against the time and check against it. But mostly is the time. So that's why sometimes gonna deliver TL, the time limit. So maybe your time complexity is not perfect. All right. So that's for this week, which is a little complimentary for a sorting topic, a very basic sorting topic, uh, uh, and abounded with previous week. All right, I guess that's all about it. And if you guys haven't delivered the code, go ahead, deliver that. And like I said, you guys have 1 month before December, though we haven't seen that firm schedule yet, but let's assume there's no surprise. It's gonna be December, gonna be 3 sessions. So like I said, you have to be very solid with all component level questions that cover in my class. And you can have a schedule, basically repeating or review the chapters for component questions, which you can check in the lecture session mostly. And the second line is the coding session. We literally have deep dive for use code questions. We talk about how to start from brute force, how to optimize code so that can deliver. So that process is very important. Instead of you just deliver the code and you check against, if you can pass it, go ahead for the next question. But I want you guys to slow down, to think about why this algorithm is justified. You have to justify why you're using data structure algorithm, where the answer coming from is brute force, where you see repeated calculation, you see redundancy, so that you can further optimize it, right? And with that, you could be more solid to handle derivative questions. And third line is, given your budget time, I want you to start challenging more use code questions, especially for the recent 5 years. For silver people who are taking my silver class, I kind of have a plan for you, but for bronze people, do please schedule time well. And this is not something we can cram into it. So we have 1 month, but still decent amount of time. So making sure you're coding, it's at least you are comfortable with coding on such a level, instead of several days before exam you cram with it, which is not going to work out. All right, so that will be the chapter for our launch meetings. I appreciate everyone's time. And any questions? All right, unfortunately, Lawrence, I'm just about to wrap it up. Is by the time you just join the session, so you can come to me offline so I can see how you can catch up. But other than that, any other questions? Alrighty, folks. With that being said, I'm going to see you guys next week for your lunch break. Alrighty, bye-bye.